Instantaneous velocity is the velocity of a particle at a particular instant in time. Unlike in average velocity, where you get the average velocity over a longer period of time as an object moves from one point to the other, the instantaneous velocity is the velocity that you see when you are driving your car and you look at your speedometer. At that instant that you are looking at your speedometer, you see a reading of your velocity of your car at that moment in time. In this case, a reading of 55 miles per hour. At the next instant of time, this velocity could change. And for that instant, there will be a new instantaneous velocity. The instantaneous velocity of a particle at position x and time t is the slope of the tangent line that crosses xt in a position time curve. Assuming that a particle moves in a horizontal motion, and as we plotted the position of that object or particle with respect to time, we come up with this graph. And we want to find the instantaneous velocity of the particle at this particular position x and this particular time t. In order to do that, we need to figure out what the tangent line is that crosses that point xt. And that is the tangent line. Remember that the tangent line is a line that touches the curve at only one point in that curve. Then we need to find the slope of this tangent line, because the slope of this tangent line is the instantaneous velocity of the particle at that given position at that particular time. So how do we do this? How do we create this tangent line? And how do we get the slope of this tangent line? To get this slope, we need the help of calculus. The slope of this tangent line is equal to the limit of the change in position with respect to the change in time as the change in time approaches zero. We actually get 2 times the initial time and the final time. What we put the 2 times very close together so that we come up with 2 positions that are very close to each other as well. In fact, infinitesimally small. That's why we have to use the limit, because we recognize that the time interval is so small that it approaches zero. We have to get 2 points because you need 2 points to create a line. But these 2 points are very close to each other. In fact, their distance is almost zero. That's why we use the limit. But if you remember in calculus, this is equal to the derivative of x with respect to t. So therefore, the instantaneous velocity of that particle at that position, at that moment in time, is the derivative of this function with respect to time. So if you know the mathematical function that describes this curve, you just get the derivative of that function, and then you will get the formula for the slope. And by getting the formula for the slope, you will get the instantaneous velocity for that particular time. So instantaneous velocity is the derivative of x with respect to t. But if you are dealing with y values, or if you're dealing with particles moving in a vertical motion, then use this formula, d sub y is equal to dy over dt. Instantaneous velocity can be positive, negative, or zero. If the instantaneous velocity is positive, that means that the slope is positive, or the slope can be negative, or the slope can even be zero. So let's look at this graph of the position versus time of a particle moving horizontally. At which time interval is the instantaneous velocity of the particle positive? Try to imagine. The answer is from 0 to 10 seconds. If you draw tangent lines along the curve from uh, from 0 to 10 seconds, you will see that the slopes are positive. Let me see if I can draw that. So if you consider this particular portion of the graph and we draw a tangent line there, we'll see that that tangent line has a positive slope. And therefore, the instantaneous velocity at that particular position and particular time is positive. Here as well, you see that the slope is quite steep and quite positive. What is the instantaneous velocity of the particle at point B? The answer is zero because the slope is zero. At point B, if you draw a tangent line, well, I didn't draw it correctly, but you will see that the tangent line has zero slope. It is horizontal. What is the instantaneous velocity of the particle at point D? At point D, if you draw a tangent line, you will see that the slope is negative. So the answer here is negative. So what are the units of instantaneous velocity? The unit of instantaneous velocity is a unit of length divided by a unit of time, or in SI units, meters per second. Instantaneous speed is the magnitude of instantaneous velocity. Let's have an example. A particle moves along the x-axis. Its position varies with time according to the expression x is equal to negative 4t plus 2t squared, where x is in meters and t is in seconds. What is the average velocity of the particle from t equals 1 to t equals 3 seconds? Letter B. What is the instantaneous speed of the particle at t equals 2.5 seconds? Notice that the position of our particle is a function of time, which means we know exactly where a particle is for any amount of time. You just substitute a value for time that you want there, and you will get the position. So let's solve for average velocity. So for average velocity, we need to get the final position and the initial position. And we just substitute the values of t equals 1 and t equals 3, where t equals 1 is for the initial position and t equals 3 is for the final position. So substituting that to our function, negative 4 times 1 plus 2 times 1 squared, we will get negative 2 meters. This is our initial position. Our final position is for t equals 3 seconds, and we get 6 meters. Therefore, our average velocity has displacement over time, where the displacement is 6 meters minus negative 2 meters. And our time interval is from 3 seconds minus 1 second. We will get an average velocity of 4 meters per second. So for letter B, what is the instantaneous speed of the particle at t equals 2.5 seconds? So what is the exact instantaneous velocity of the particle if we look at the speedometer at exactly 2.5 seconds? For that exact moment, what is the instantaneous speed of the particle? Well, we just use the formula. The instantaneous speed is the derivative of x with respect to time. And we can use this because we have a function for the position with respect to time. It's given in the problem. So we get the derivative of the function negative 4t plus 2t squared over dt. And if you remember your calculus, that is equal to negative 4 plus 4t. Remember that we move the exponent downwards and then we subtract 1 from the exponent. So negative 4 plus 4t. Now that we have an expression for the slope of this curve, we just need to specify which part of the curve we need to find the slope of by substituting the value of time that we need. So we need the slope at t equals 2.5 seconds because that's what asked in the problem. So that's what we do. Negative 4 is 4 times 2.5 will give us 6 meters per second. So at t equals 2.5 seconds, our particle has an instantaneous velocity or instantaneous speed of 6 meters per second. Thanks for watching. Bye-bye.